Hi there, grade 11s, and welcome to today's physical sciences lesson. We're going to be talking about solutions and concentration of solutions today. But what I want to do before we get into that is just do a quick recap and a quick overview of what we've been doing up to now. Because in a lot of ways, even though we've been working with gases, they play a part in the calculations we do in stoichiometry. Now remember, stoichiometry is moles and molar gas volume and all those sort of things. So we're going to talk about gases in that section. Today specifically, yes, we are going to talk about solutions and concentration of solutions, but I just want to bring it all together so that as we go forward, you don't forget about gases when we then have to take them into account in our calculations. So look at the board with me and we'll get started. What have we done up to now? We've been working with gases, and when we talk about a gas, we use this calculation here. Now, I know I'm jogging your memory from grade 10, should I say, and you might remember it as being written like that. And this value at the bottom here is known as the molar gas volume, and it is 22,4 cubic decimeters. So I've got the word molar gas volume down here. And for those of you that can't remember, I'm going to show you quickly how we got to this value, okay? What scientists did was they took the ideal gas equation, remember this, PV equals nRT, and with a pressure, well, let's do this. They had a pressure of 101,300 pascals. Didn't know what the volume was. They used 1 mole, and the temperature was 0 degrees Celsius, which is 273 Kelvin. So multiply those together. They ended up with a value of R. Now the value of R is 8,31. Okay. Now scientists then did a little bit of thinking, and they then put gases in actual practice. They put gases at 0 degrees Celsius. They made sure there was 1 mole of gas, and they then discovered that if there's 1 mole of gas at 0 degrees Celsius and a pressure of 101,300, so 101,300 pascals, the gas is going to expand so that it takes up a volume of 22.4 cubic decimeters. So they've proved this mathematically and they proved it in practice. And that's where we get our number from. So at 0 degrees Celsius, and 101,3 kilopascals, also known as standard temperature and pressure, our volume is 22,4. And what we've got at the top of this would be the actual volume. So that would be a case of if I say I have got 3 cubic decimeters of nitrogen gas, how many moles are there in 3 cubic decimeters? What I'm going to do is I'm going to go 3 divided by 22,4, and that's going to give me my number of moles. Okay. Another way to calculate moles is mass over molar mass, or molecular mass, or relative molecular mass. Now remember, molecular mass is where we add up all of the masses of a particular substance, or the atoms within a particular substance. So for example, let's do water. Water is quite an easy one to just think of quickly. The mass, if you look on your periodic table, of oxygen is 16. The mass of hydrogen is 1, and there's 2 of them. So I'm going to go 1 times 2. And to get my molecular mass, I add those 2 numbers together. So I'm going to have 2 plus 16. It's going to give me a mass over my molecular mass, which is 18. Okay, so hopefully we're starting to shake the cobwebs a little bit. This is all grade 10 work. Okay, now what we're talking about today in particular is going to be this one over here, which is concentration equals moles divided by volume. Okay, our volume is going to be in decimeters cubed, and you know that the unit for moles is mole. Okay, so we're going to be talking about calculating the concentration of various things. And at the bottom of the screen, you will see that I've got the word titration, and you'll see that I've got the word precipitation. Okay, now I've put those two words in just so that we can have them in our minds. We're aware of them because those are two places where we can use this concentration calculation. Okay, another one that I didn't add in, but I'll put in now, is when we're talking about the dilution of substances. Okay, so the three areas where we can really be tested and really be what's the word I'm looking for, challenged, is in the precipitation section, in the titration or acid-base section, and in when we're diluting substances for practicals. Okay, so this is a very important calculation or equation, so that's why we're spending some time on it today. So let's see what else I've got in store for you. Right, let's go through what concentration is. So the concentration of a solution is a measure of the number of particles of the solute in the solvent measured in moles per decimeter cubed. Okay, so the concentration of a solution, so remember a solution is a mix of solid and liquid. It's a measure of the number of particles of the solute. So the solute is going to be your solid that's going to dissolve, and the solvent is going to be your liquid. Okay, so the solute is going to give us our moles, and the volume is determined by the amount of liquid that we use. Okay, so I'm not going to mess around today. I've got lots of examples for you to do. So I've got the first one here, and the first one reads as follows. Calculate the concentration of an aqueous solution. Right, let's just stop there for a second. Aqueous solution is another way of describing a mix of solute and solvent. Okay, it's normally ionic solution, so you've got an ionic solid that's dissolved in that, so sodium chloride or potassium bromide or calcium oxide, something like that, where there is an ionic bond between the substances and that then dissolves in a solvent. A good solvent for those sort of substances is water. And you'll see a lot of the examples that we work through today will be a solid, ionic solid of some sort dissolved in water. Okay, so aqueous solution, here it means that there are ions dissolved in water. Okay, in water. All right, so calculate the concentration of an aqueous solution of sodium chloride, and there's my ionic substance. Okay, the mass, I didn't add the word in here, so let's put the word in. Mass is 127 grams of sodium chloride, and that's dissolved in 375 cubic centimeters of water. Right, so now there's a few things we need to talk about here. Let's just make a note of the information we've got. So mass is 127 grams, right? The substance is sodium chloride. Right. What am I going to use for this calculation? I've given myself some space. I am going to use C equals N divided by V. So now if we have a look at this little equation that we've got, there's two parts to it. Number one, we need number of moles. Number two, we need volume. Okay, so moles I don't have at the moment. All I've got is a mass. So I'm going to have to do a second calculation where I use mass divided by molar mass to work out my number of moles. So once I've done that, I'm able to substitute that value back into my original equation. The second thing I have to do is check my volume. Okay, so the volume has been given to us in 375 cubic centimeters. Now, cubic centimeters is one way of describing volume, but for this particular calculation, remember I said to you, it's in cubic decimeters. So I will need to do a conversion. How do you do a conversion? So let me just do a quick recap. I know we're looking back now at sort of grade 8 and grade 9 work, but these things are important because you do need to do them. You do need to do these conversions quite often, and sometimes we forget. So a little bit of a recap here. There are 10 centimeters in 1 decimeter. Okay, so if I am going to convert from centimeters to decimeters, what I'm going to do is I'm going to divide by 10. Okay? If I'm going to go from centimeters squared to decimeters squared, the really nifty thing is I divide by 10 squared. And the part that applies to us, if I go from centimeters cubed to decimeters cubed, I'm going to divide by 10 cubed, which is the same as 1,000. Okay? So my second thing that I have to do is I need to do a conversion. Okay, so let's do it in those two steps. So starting with calculating number of moles. So let's do this. Moles equals mass over molar mass. Now, I don't have a periodic table on the board with me, but I know that you've got it in your class, okay, and I've got one next to me, and we're going to talk about the masses of sodium and chlorine. Now, I know that the mass, the molecular mass of sodium is 23, and the molecular mass of chlorine is 35.5. Okay, so I've got 127 grams, needs to be divided by 23 plus 35.5. Now, as with everything, we will need to look at our calculator. Every calculation, we need to go to our calculator. So let's see if we can find it. Come as the calculator. Right. I'm going to use my fraction button. I'm going to use 127, 127, and I'm going to divide that by, and I like to use my brackets, you know that, 23 plus 35.5, close my brackets, and move the arrow to the side and get an answer. SD that, and I get an answer of 2,17 moles. Okay, which is cool. So I've got my first part. Let's just do our conversion quickly. I have got, I have got 375 centimeters cubed. So this is part number 1. Part number 2, I've got to go 375 divided by 10 cubed. You can use your calculator, or hopefully you're able to do this in your head. I'm going to get an answer of 0,375 cubic decimeters. Okay, so now we are A for away. We've got all the information that we need. So now we just plug it into our calculation. Right. C equals N over V. In fact, let's just do this in a different color so that we know C equals N divided by V. My number of moles I worked out as 2.17, and my number of decimeters is 0,375. And if I put the two of them into my calculator, comes the calculator, let's clear it, 2.17, and here I'm going to go 0.375. Come on, there we go. And I'm going to get an answer of 5,786, or I'm going to round that off to 5,79. Now, I can't forget about a unit, because with everything in science, if you do not have a unit that accompanies a number, unless it's a ratio, okay, unless it's a ratio, if you do not have a unit that accompanies a number, that number is actually meaningless. Your answer is meaningless. So you always need to put in a unit. So my unit here is moles per decimeter cubed. Okay, 3 steps. So it was 2 steps to get us to our final step. Okay, we had to calculate number of moles, then we had to calculate volume. Now, not every sum is going to be like that. Some you're going to be given all the information and you just need to do the final answer. Others are going to be a little bit more involved, like this one. So let's see. I've got this question here for you. Okay, we are going to have to go to an ad break soon, so I'll let you go to your ad break and then you can come back and do the work there. But there's one thing I need to point out here. My volume is in a different unit. All right. So again, we need to know what the conversion is here. And for this, 1 milliliter is equal to 1 centimeter cubed. Okay, and remember, we've just spoken about how to convert from centimeters cubed to decimeters cubed. Okay, so I'm going to write down what I think we're going to be needing. And then from there, when we come back from our ad break, we can then work through this question. Actually, you know what I want to do? I'm going to leave it for you to do. I'll give you a few minutes to do it. Then we'll come back and we'll work through it together. Okay. So it's going to be if 162.35 grams of aluminium hydroxide, so we're going to need to find a periodic table while we're on ad break. They're dissolved in 6,750 milliliters of solution. What is the concentration of solution? Does it matter what the solution is? No, it doesn't. Okay, I said to you it's normally water. Doesn't matter if it's not. Okay, so while we're on ad break, you need to scramble around and find a periodic table. Hopefully there's one on the classroom wall. If not, look in the back of the textbook that you've got, okay, because we're going to be needing it as soon as you come back from the ad break. So I will see you shortly after this. Hi everybody, welcome back from the ad break. And like I said to you just before we went on ad break, I've got some for you to do. I've given you the bits and pieces that you're going to need, and the rest of it is for you. And 37 and 32 and 16 times 4. Let's just put this in brackets. I know we're nearly out of time, so just do this quickly. 16 times 4. Sorry, I had to shout at the calculator. Gives me 233, and I'm going to multiply that by 0.25. And my answer is going to be 58.25. 58.25 grams. Sure, okay, and that's us. Skidded in at the end there. Went a little bit over what we should have, but hopefully that's helped you, and I look forward to seeing you in our next lesson.